possible, can we reconvene in a...
All right, folks. Welcome back. I hope everyone had a good break, stretch of legs. Welcome back to this network ops session. With me, I have Shishio Tsuchiya-san, who is my co-moderator. So, folks, before we start, just I'm sure by now everybody knows the basic housekeeping. Please be mindful of the code of conduct, which is available both on the APRICOT website and also the links will be shared on the chat window. If you have any questions, please use the Q&A button for your questions. Zoom chat, preferably, we would request you to please keep your questions in the Q&A because the Zoom chat window will be for sharing any housekeeping links or information for you all. And as always, please feel free to take photos of yourself, share it online. And if you have any follow-up questions, feel free to send them across to the secretariat at apricot.net. With that, without further ado, I would like to hand this over to Tsuchiya-san now to take over the session. All yours.
Okay, thank you for the introduction. And let's start the network operation session. We have 3 presentations and 4 speakers. And I try to introduce. First speaker is Wilson Cho from FutureGen International, who will talk about how ProjectBASS data provide useful for many applications. Wilson.
Yes, hi.
Yes.
Can I start?
Yes, you can.
All right, let me share my screen. Let me know when you are able to see my screen.
Yeah, good. We can see.
Okay, so I'm one of the co-founders of BASS, ProjectBASS.org. We are a crowdsourcing and mapping solution for Philippine internet. And so we start the presentation with a short video to highlight what we do. So BASS is like a commercial speed test offering, but our advocacy gives it out for free. So the way it works is that BASS mobile app is installed on a mobile phone, and when it is run, it collects bandwidth and other data for BASS to crunch and convert this into actionable intelligence. So here you see the app being started. So users just press begin, and it starts to measure the bandwidth and collects the cell site information as well. Those are the data that we collect. And you can even look at the map. So our map shows the most recent 10,000 measures so as not to clog up the server. And so that's a quick video explainer of ProjectBASS. And here's the schematic diagram. The BASS app is on GitHub. So any volunteer developer can take a look at that and they can suggest a fork. So we use a multi-server approach with each specific function hosted on a different server. So for step 1, the volunteer will visit the ProjectBASS website to download the mobile app. Once they have that installed, they go to step B, which is just to run the app and make a measure. The base file is located in the Philippine government's DOST/PHOpenIX server to provide for a neutral measurement. Then finally, the results are saved in our Singapore server. Note that we download a fixed file from PHOpenIX and measure the time to compute the bandwidth speed. We only measure download speed. Now, how is ProjectBASS different? Here are several things that stand out. First, for computation of bandwidth, we only include the peak periods. Then we also only use median instead of the mean to compute averages. We find that median is more robust against large outliers that could skew the results. Number 3, we measure from a single central location that is neutral to all Philippine-based ISPs and telco. And this is from the DOST PHOpenIX location. Number 4, we use data and spatial analytics to provide useful and actionable insights. So that's generated every week. Number 5, we use machine learning for data validation and anomaly detection. And finally, number 6, we support open data. All of the data collected by our volunteers are freely downloadable. And how are we finding ISPs using our data? Well, it surprised us to find out that they actually use it as a proof of activation. So for last mile or subscriber installation, a ProjectBASS measure is required of their installers to ensure that number 1, the subscriber is activated, and number 2, the correct bandwidth has been allocated to new subscribers. For the larger telcos, a ProjectBASS measure is an objective means to verify that new cell sites are properly commissioned. Each BASS measure contains the LAC, MNC, and CID that verifies the tower identity. Telcos can use this unbiased method to prevent fraud, like having ghost cell sites. For validation of complaints in Italy, I met up with ADCOM director, where they use a similar service to require a proof before a complaint can be lodged by a subscriber against a telco. Then in the next succeeding slides, we will show how ProjectBASS can be used to monitor quality and to track sentiment. So here on the screen is how an ISP might use BASS for quality assurance purposes. This chart shows that for each of the 2 buildings being monitored, the first floor and the MAT building, 3 readings from each Wi-Fi zones are taken. These are the readings taken during 2018. And then for 2019, another set of readings from the same Wi-Fi zones were taken, and they were then compared to the 2018 readings. So this is one way that ISPs can track any service degradation over time. Next, ISPs also can use it to track sentiment. The BASS program actually does a survey to ask the users about their happiness levels. So here we show the happiness levels for the 3 telcos. Green is for Smart, blue is for Globe, and the third entrant, red, is for Dito. And so we see over time how the sentiments of their subscribers are changing. Then also we see that the BASS data can also be used or are being actually used by regulators. Here they can see the effect, if any, of the impending arrival of new players, like in this case, Dito. And from the chart above, you will note that the new player does not significantly alter the service offerings of the existing 2 telcos to the public. So for lawmakers, this might mean looking into repealing some archaic provisions of the law that stifle competition. Again, for lawmakers, we have been able to show the effect of competition on bandwidth, principally by segregating the results into the mobile and the Wi-Fi. as you can see, or most of you may not know this, in the Philippines, there are only 2 mobile players, and their combined bandwidth is shown in blue line. However, the Wi-Fi is our proxy measure for fixed or broadband internet. And in this domain, there are several more players. Here we throw in the cable TV operators that also double as ISPs. And you can see that as a result of higher competition, there is a significant gap in the bandwidth improvements over time. Next, our data can also be used to study inclusivity, specifically digital divide or any social inequity. The chart on the left is for Metro Manila, and the one on the right is for Mindoro province. Cell sites are shown as circles, and these are color-coded to represent the various network. Green for Smart, blue for Globe, and red for Dito. While Metro Manila is studded with cell towers, the less urbanized area of Mindoro, in stark contrast, is comparatively bare. Then again, here we partner with the Department of Education, Leyte Province, to do a massive bus testing during the 3rd week of February this year. We then crunched the results and gave it back to DepEd as a map down to the barangay level to help them visualize the bandwidth profile of each of the barangays in the province of Leyte. Here, areas with the base map colors are the ones that are presumed to have dead spots or no coverage. Red areas are those with poor to low bandwidth, while the green areas are those with enough bandwidth to sustain online education. Here we also show the map of actually active DICT free Wi-Fi zones in the entire country. If you count all these dots, there are 372 out of the supposed 4,000 over Wi-Fi zones that are supposed to be active. Next, we collaborated with health organizations to study the feasibility of enabling telemedicine. The map shows that for certain areas, this is not yet feasible. What we did here was to do a spatial analysis to connect each of the health centers to the nearest cell site. And so each line displays the line of sight from a health center to the nearest cell tower. Each health center is shown as a red cross. Here is a data that we crunched and displayed as a radial chart for subscribers. And this is how it works. Each of these inner circles represent a region. And so a user simply needs to click on a particular region, like here, for instance, Eastern Visayas, and the radial chart will drill down to a subset of a radial chart. This time, the other circles here represent provinces inside the region. And when you click on Leyte, it now again drills down to a specific municipality. And at the level of that municipality, we rank the telco providers according to the median bandwidth that they have. So in this case, for Ormoc City, it's PLDT Smart. We also crunch our data to help subscribers determine handset models. So we do a scattergram with the x-axis showing the signal strength of each handset, and the y-axis showing the median bandwidth measured for that specific mobile phone model. The better handset models are the ones that can get the highest bandwidth at the lowest possible signal. In this case, these are the handsets located in the upper left quadrant. You will also notice that there are handsets with negative 1.0 signal strength. I assume that these are the newer 5G phones. Next, we provided data also for economic analysis. In this case, ProjectBASS data was used by the World Bank to study cell site deployment of the Philippines versus ASEAN. And when our data is combined with advanced machine learnings like the ones done by thinking machines, they came out with a conclusion that poorer areas have actually less access, slower internet speeds, and fewer cell towers. And our roadmap for improvement is to come up with a desktop version, and future releases should also collect radio frequency usage to map the radio spectrum usage for the entire country. We would also like to have store and forward capability to enable us to identify and detect dead spots. We also plan to come up with a free Wi-Fi map area for the entire Philippines. And finally, we would like to collaborate internationally. So even though we started off in the Philippines, we now see that BASS is being used from all continents of the world. And so you can see a lot of circles around the world. And this could not have been possible without support and promotion from the OST, Manila Bulletin, Preginet, DOST, ASTI, and we were nominated and won the country category for the World Summit Awards. This is our team. The person on the upper right is Paul Sidney Orozco. He was the major contributor of the code for BASS. And with that, I end our presentation. Thank you.
Thank you for your presentation. And I will check the Q&A box. I think there is no Q&A box, but I think this information is very useful, and the project will be useful for the deployment of Wi-Fi and cellular network. And I also download your software now. And
thank you.
Thank you. Okay, then if there is any question, then please reach out to our email or Wilson directory. And let's move to the next slide. Wait. We have one Q&A. Can you see, Wilson? Can you see the Q&A? I will read. When is the desktop version going to be released?
Very good question. As you know, ProjectBASS is a purely volunteer-driven initiative, and so we depend on the free time of our core developers. For the desktop version, if you or any hotshot developer out there want to contribute code, as I said, our base code is on GitHub. We encourage people to help us roll out these new features.
Very good. Thank you. And one more question. Do you have a data of cellular density per LGU?
Cell site density per LGU. Yes,
Yep.
actually we have data down to the barangay levels. But density in terms of square area or density in terms of population? So Gio, can you clarify? How do you want us to compute? Okay, so for population, we have the latest census as of 2015 population data. But it's only down to the municipality level. So we wait for the 2020 population census to be out.
Good. I think good. And one more. Are you able to provision the solution as a browser-based model instead of pre-owned?
Yeah, we do get this request a lot, Harish Pillai. Two things though, we need to realize that for some operators, a desktop solution is being used to game the system. So what do I mean? They can run scripts on top of a desktop solution to keep on submitting data. And we're not really sure if we want to be in such a scenario. Having said that, we do also realize that there are a lot of volunteers that want to help us with measuring their desktop bandwidth. And so again, that is in our roadmap, but we are just waiting for volunteers to donate their time and resources to help us deploy a desktop version. And because we're a volunteer organization, unfortunately, we cannot pay our developers. Instead, credits that you are the one that is responsible for delivering such a feature.
Thank you. Yeah, I think it's okay. It is very great discussion, and thank you. I'd like to thank you again. Thank you for our presentation. I will move to the next session. Next session is Matsura-san from JPRS and Yano-san from Optage. And they are with presentation deployment of TLD Anycast node to ISP called stability and resiliency. Matsura-san.
Hello, I'm Matsura. Can you hear me?
Yeah, we can.
Now I'm sharing the presentation.
Yeah, good.
Okay. Now I'm starting. Hello, everyone. I'm Takayasu Matsura from JPRS, CCTLD Registry of Japan. Today, I'm going to talk about deployment of TLD Anycast node to ISPs for stability and resiliency. The talk is about the activity done by JPRS and some of ISPs in Japan. Yano-san from Optage will explain some of the slides with me.
Matsura-san, can you change to the presenter mode and can you on the video?
Okay.
Sorry, disruption. Good.
Okay. Sorry, I will be presenting wearing a mask. Okay. Next
and
slide.
could you change the presentation mode instead of presenter mode? Slide show mode. Oh. Good. Great.
Okay. Sorry. Okay. In this slide, sorry. Okay. Here is an outline of today's talk. The project is continued from the experiences we presented in APRICOT 2021. It is about the experience of DNS local nodes. In this slide, I'll explain briefly about JPRS TLD and what we've done in 2017. First, JPRS TLD is a place where we can do the experimental activities of domain names and DNS operations in real internet. Using this TLD, we can test and evaluate the new technologies and the stuff which has technical difficulties to directly implementing in production environment. And I'll introduce the joint research held in 2017. As Japan is a disaster-prone country, there is always a possibility that the internet connectivity may be cut by an earthquake or such. So is the collaboration with domestic ISPs in Japan. We've done a joint experiment to verify the effectiveness of deploying the TLD DNS servers within the ISP's network. There, the name resolution should be continued even in the case of physical internet divide has happened. The presentation material for the 2017 experiments is in the URL shown. Okay. Here is the background of Joint Research 2021. The Tokyo Olympic Games are scheduled to take place in 2021. But because of the worldwide pandemic of COVID-19, I have no idea if it will be held or not. However, during the past Olympic Games, large-scale cyber attacks do happen at every Olympic Games. Especially DDoS attacks occurred in larger than 100 gigabit per second scale, and that led us to prepare before the game started in Japan. Okay, I'll explain the logical structure of the internet in Japan. Japan is the island nation, and many submarine cables. Oh, sorry. Japan is the island nation, and many. Okay. Japan is the island nation, and many submarine cables from other countries are landing on Tokyo and Osaka areas. The internet exchange are also concentrated in Tokyo and Osaka as well. A bunch of Bluetooth servers and TLD DNS servers are also located there as well. Most of the domestic ISPs in other areas are bringing in their lines to Tokyo and Osaka and connect there. If the large-scale DDoS attacks happen there, the DNS servers cannot respond to the clients, and the ISPs in other regions also may not resolve the names. They will virtually lose access to local internet resources. We call such situation logical internet divide. By considering the background and the logical structure of the internet in Japan, here is what we've done in this project. The goal of the project is to verify the effect of deploying the local nodes against the logical internet divide. Deploying the local node is to place the TLD DNS server within the ISP network by BGP Anycast technology. In this exercise, we simulate the DDoS attack during the Olympic game period and verify that the ISPs with the local node can sustain the name resolution. In the last part of today's presentation, along with the result of 2017 and 2021 exercise, we have considered how to deploy the local node within Japan. Okay, I'll introduce the ISPs and the DNS server location for this joint research. JPRS operates global node at Tokyo and Osaka, and one more is located worldwide. In the exercise, we've added local nodes at 3 domestic ISPs in Japan. One is Optage. Yano-san from Optage will explain some slides later. And Hotnet at the Hokkaido area and QTNet at Fukuoka area also joined the exercise. Next is the exercise scenario and the measurements we've done. In the first scenario, we've conducted the DDoS attack to the global node only situation. You can see that as number 1 and 2 in the figure. Next, we've deployed the local nodes and conducted the DDoS attacks as shown in the figures. They are number 3, 4, and 5. As for the measurement, the probes are placed on the internet. and we've checked the response from the DN servers. The probes is in the ISPs with the local node are used for the measurement as well. This slide, the results along the scenarios are described in this slide. The situation changes along with the scenario number 1 to number 5. For each situation, the measurement results from the probe placed on the internet are shown in the graphs. The vertical axis of the graph is RTT from ping results in milliseconds. Horizontal axis is the time. The time period when the graph is interrupted indicated that the DNS response is not being returned. Scenario number 2 shows that the global node is not responding at all because it is being attacked in a situation where there is no local node. On the other hand, the graph of scenario number 4 shows that the local node is able to respond when the global node is under attack. Scenario number 5 shows that the local node is under attack, but the local node is able to absorb the attack. By combining global node and local node and deploying them in Japan, we are able to confirm a certain effectiveness against DDoS attacks. Thank you. Now, Yano-san, please make your presentation.
Thanks, Matsura-san. Hello, I'm Nagisa Yano from Optage, and I'd like to start with a brief introduction to our company. Please excuse me for speaking with a mask to prevent COVID-19. Optage is the telecommunication carrier located in Osaka, Japan. Our representative services are FTTH, which has 1.6 million subscribers and cover Kansai region, and MVNO, which has 1.2 million subscribers and cover all over Japan, and Solution, and so on. Next, I'll explain our motivation for this experiment from the point of view as one ISP. First, .JPRS registry operator is the same as .jp, so that we can conduct the experiment assuming our production environment. Furthermore, this graph below shows that the number of registered domains by TLDs. It can be seen that many important customers use JP domain. Therefore, we thought it meaningful to join this experiment. Then let's talk about the results. This graph indicates ping RTT from the full resolver inside of our experimental network to the authoritative name server. It shows that the authoritative name server was switched from global node to local node at switch point. At the station 2, obviously it was not responding, but at the station 4, it was. The next, this graph indicates big RTT from local node. The probe set up inside of our experimental network to the full resolver, which is also set up inside of ours. Domain name can be resolved by local node at the station 4, which is what we most wanted to make sure of. We assumed that some singular points, like this point, approximately 1,500 millisec, status was no error, caused by temporary server delay due to heavy load. To summarize my presentation, as general comments, finally we found it effective to locate local node in ISP network. And local node makes it possible to resolve domain name while global node is being attacked. Also, we can deal with local node down because it occurs only when attacker's source IP is ISP users. And our future tasks are as follows. The first is the trigger and the timing to switch from global node to local node and vice versa. The second is the method of zone data synchronization between global node and local node. The last is the redundancy of local node placement, which depends on the time it takes to recover global node. That's all for my presentation. So I'd like to hand over to Matsura-san. Thanks.
Thank you, Yano-san. Okay, I'm Matsura. In this slide, I have explained about the verification of the DNS server behavior in the situation of cyber attacks. In this project, we have also conducted a joint research training at the cyber attack situation. The training has done for the situation that the attackers may exist within the ISPs, even if the local node is deployed too. The detection of the cyber attacks in relation to the ISPs, jointly responding to the attacks by TLD operators and ISP operators has been done. In this training, we prepared a simple attack detection system and notified the TLD operators of the attacks detected by the system, and shared the information with the ISP operators using Slack and email. Now, lessons learned from the training. There are many voices that these communities make sharing the information in the initial phase of the attacks easy. And even if the attacks ended without large damage, sharing the information can lead towards the future countermeasures. However, we've also heard that in practice, each ISP has its own operation body and contact point. Thus, the way to collaborate will be different among ISPs and may not be single method within ISP. In addition, by the information request via Slack or emails, they also need to check the existence of relationship contract to have the clear evidence to treat as formal request is needed. To start the real operation, we need to prepare the system and contact points. But informal committee using the tools like Slack among ISP operators is quite important. Okay, so this is the last slide. We have considered how to deploy the local node within Japan. From the physical point of view, Japan is the island nation with many submarine cables landing on Tokyo and Osaka area. We should deploy local nodes in each island. From the logical point of view, the networks and DNS servers are heavily concentrated in Tokyo and Osaka. It is ideal to deploy many local nodes within the location to withstand the cyber attacks. However, deploying the local nodes in each prefecture, we have about 50 of them, is not realistic. We need to determine the preferred locations. In Japan, there is electric power companies covering each different geographic areas, and deploying the local node within that areas would be the best effectiveness places in both logically and physically viewed. That's all for our presentation. If anyone has experience of doing this or that in the past Olympic Games, I would like to hear about it. Thank you for listening.
Thank you for presentation and share your experience. And let's move to the Q&A session. We have one Q&A. Can you see, Matsura-san, can you see the Q&A?
Okay.
At first, I will read the question. Thank you for Matsura-san for the interesting presentation on the JPRS experiment. Will the local node continue to be deployed post-Olympic as a part of continued resilience?
Okay. In this experiment, we applied a local node in the .jprs TLD, but we are considering to provide it to JPDNS continuously in the future.
Good. Is there any other question? Okay. One more question. Where you mentioned only J.jp or .jp plus some other TLD. How about some other TLD?
Excuse me, can you clarify the question that, are you asking that we are going to deploy local node on JP only, or in addition, also applying to .jprs or the other TLDs we operate?
The journal is say yes.
Okay, thank you for clarification. And we have done this experiment in .jprs, and as Matsura-san told, we are considering to deploy local node for .jp, but currently we have no plan to deploy local node for .jprs in future. Thank you.
And the two question, were there any notable challenge with regard to deployment the local node? Was there any notable challenge?
Okay. So cost effectiveness must be considered when deploying local nodes.
And the last question. And usually, how do you deal with the attack found in the local node? Is that by black hole or something else?
Thank you for your question. We have not suffered which targeted to .jprs TLD, but in case we under attack, massive DDoS attack, possibly we will ask to filter the traffic in the ISP, which deploys a local node. Thank you.
Okay. Okay, then we have a lot of Q&A. So if you have still some question to the Matsuda-san and Yana-san, please use this Q&A box, or please contact to the email. Thank you for Matsuda-san, Yana-san.
Thank you very much.
Thank you very much.
Okay, let's move to the last session. And the presenter is Piora I'm sorry, Piotr from a shadow server.
Piotkiewski.
I'm sorry. Okay, and securing your network using this shadow server, the daily network report. Please
I need
share
permission to share the screen.
Matsuda-san, Yano-san, could you stop the share the screen? Yeah, good. Maybe you can share now.
Okay, can you see that?
Yeah, good. Great.
Okay, thank you. My name is Piotkiewski, and I'm here to talk about how to secure your network using shadow server reports. These are free reports that the nonprofit foundation Shadow Server provides. So as a way of introduction to the presentation, the reality of today's risk on the internet is that essentially everybody knows about the exposure footprint of your organization. There are many organizations and as well as bad actors, legitimate actors and bad actors who scan your network. A lot of information is collected and shared. You can use third-party services to discover a lot about other people's networks. And essentially, nowadays, you can assume that bad actors have essentially very good knowledge of what you have exposed and essentially how to exploit it. And that is a really critical thing to answer is what can others see when they're looking into the network from the outside. Essentially, networks have grown very, very complex. In terms of many organizations have essentially hundreds of thousands of nodes out there, many of which are exposed, scattered across the world. And the picture and the current status of this exposure changes all the time. So it's not static, and tracking all of that is a pretty difficult process to maintain. Even for a small organization, it's very easy to make a mistake and expose your services by accident, even for an hour a day, leading to a potential risk and essentially a compromise or a data breach. So would it be nice if there was an organization that actually monitored all of this for you for free and shared with you all this information for free, and not selling or reselling it to third-party entities. And this organization is Shadow Server. So as Shadow Server, we actually monitor a lot of sources that give us kind of like an external view into your organization. And we do it through a variety of different techniques, from scanning to operating honeypot sensors, infiltrating malware botnets, operating sinkholes, doing a lot of malware analysis at scale. And essentially, we process trillions of these events every day, and share it with you and the community entirely for free. So yes, what we do is essentially right now at the moment, every day we share data with around 5,900 vetted subscribers. These are network owners, entities that own a network around the world, or anyone that owns a network around the world, or also to national governments. We also provide data to national governments at the country level for their national certs or other national government institutions to have a good picture of essentially vulnerabilities in the country's infrastructure. And well, these reports are very detailed. They are very actionable. They provide you specific IP information and specific information about a problem. They are relevant to your network, so we tailor the report just to your network, which means that if you just get reports that are relevant, that apply to your network address space, not to somebody else's. And most importantly, they are for free. And yes, anyone that owns a network can subscribe. And I think the key thing is that if we are able to see a problem in your network, then it is likely that all bad actors, everyone else that actually scans and observes your network, can actually see the same problems and potentially exploit that problem. We never exploit these problems. We don't. We just the only thing we do is essentially just do like normal connections. We don't hack into networks. The only thing we do is collect information as if it was just a benign connection if we scan, and then report that to you. So we have been doing this for around 15 years already, even more than 15 years. And over time, we have partnered with a lot of entities around the world. A lot of vendors use us as a kind of trusted third party to distribute data. We collaborate with national certs around the world. We collaborate with law enforcement on takedown operations against cybercrime botnets, and also with researchers from around the world. So essentially, we act as a kind of a clearinghouse for threat intelligence feeds at a very large scale. So essentially, whenever we actually discover something new worth reporting on, we either embed it in an existing reports type, a particular feed format that we serve, or we create a new feed report, and then anyone that actually subscribes to our feeds automatically gets these reports. And essentially, each network report includes exact details of the problem, and we also provide some pointers to recommended actions that can be taken. And currently, we have over 80 different network report types. This includes, for example, optional report types, which we do sometimes for just to inform you of certain populations of assets on your network. So for example, we can maintain an SSL certificate inventory for your network automatically because we scan and collect like 50 million certificates every day. And if you subscribe to our services, we can tell you what certificates we give, we see on your network. So not necessarily just like vulnerabilities, but just we can actually serve as an inventory of your exposed assets. So how do these reports look like? For example, we inform about this is one specific report about brute force attack attempts. Essentially, we using our honeypots, we collect a lot of attempts to connect to our honeypots, and quite often nowadays this is related to IoT malware like Mirai and other lookalikes. So we monitor for connections and bad actors attempting to hack into routers and other IoT devices. And whenever we see that coming from your network, we will immediately report that out to you. And this is essentially in the form of CSV related data that will be shared to you daily with specific IP information. So this is just one of the 80 reports, and we see about hundreds of thousands of these brute force different IPs attacking every single day. So the scale of these attacks is pretty big. Another one big important source of our data essentially comes from collaboration with law enforcement and the industry and taking down known threats and actors, or acting as a distribution mechanism for collected data. So here you see a history of various shadow server related efforts for the last 15 years or so, where we were somehow involved as part of all these operations. Many of them you can recognize, and that includes some interesting latest ones like the Sunburst and Emotet, where in the case of Emotet, we actually distribute feeds from that takedown by the Europol FBI and the German police and others. And I think few people know that we actually also operate the Sunburst sinkholes, so the domains that were used for the SolarWinds hack, and where are currently controlled by us, and we can see who is actually making queries to these domains and inform of potential issues related to that. So essentially, if you own a network, if you have an ASN or a CIDR range, even a couple of IPs, even one IP, if you operate services somewhere in the cloud, if you have a domain, or if you are a whole country, at any of these levels, you can actually subscribe to our services, and again, get them for free with no obligations, no catch of any type. The data is there, it's free, and will always be free. So how can you get started? Essentially, it's very simple. There's a very simple application process. You just have to visit our website, and in the upper right corner, you'll have an orange button, subscribe to reports. And all you have to do is essentially provide some basic information about yourself, which is needed to verify your identity if you are who you really are. So we're sure that we're actually giving the data for a particular organization or network to the right person and the right organization. You can provide your ASNs, CIDR block, domain names. If you're a national cert, you provide that information as well, and essentially provide a list of potentially an email address where you'll get either the reports or notifications about the reports, as well as a potential list of references that you can provide that will help us verify your identity. Again, there is no formal agreements. We will try to do some checks if you are if you say you are who you really are, and then provide you the data. So it's all about trust. We operate really based on trust. We have quite a lot of trust relationships in place. And this is something that, again, has been like 15 years of the basis of operations. And even if you think that you may be overwhelmed by the information or are a bit distrustful of an organization that's called Shadow Server, because the name, I guess, can be scary in some ways, you don't really have to. We are absolutely harmless in that. So please subscribe. You can start small and see how that works out for you, and then expand maybe to other reports. It's really up to you. So again, to be clear, we provide. It's only you who gets your data, right? We will give your data also to national certs and your ISP as a network owner, but we do not actually resell or do anything of that type with the data that we collect. And even if you don't subscribe, similarly to other organizations, that's everybody that scans the network, we collect your data anyway. So it's good to actually be able to give it to you so that it serves and helps you maintain a good security posture. There are different forms of data access: email, report file download links. We have a web space with report files or an API that is in a beta phase to which you can gain access to. And reports are always in CSV format, so they are easy to parse. There are tools out there, open source and also commercial, that can help automate things for you if you're overwhelmed with the amount of data. And same with national certs, they can get our data at a country level. If you're a national cert in a country that actually in the Asia Pacific that doesn't get our data, then you can subscribe to it as well. Currently, 120 national certs worldwide gets our reports on a daily basis. So quickly walk through examples. For example, if here's an example of the things we report out. For example, report out Emotet infections. Emotet was a pretty widespread malware that was behind many of the sophisticated attacks, cybercrime attacks out there, till essentially the start of this year when it was taken down by Europol and other entities. And we are distributing this data from the law enforcement sinkholes. So if you're an organization that's affected by this and you subscribe, you will get information from us immediately on which machines in your network are compromised. Similarly with Sunburst, we operate Sunburst sinkholes, so we actually see the connections to these sinkholes and also the DNS queries where there are many DGA encoded domains that have a lot of victim information in them. If you subscribe, you can get this information from us as well. Again, all for free, no strings attached. If you are a mobile telecom operator and you'd like to have awareness of what is happening in your networks on a daily basis, again, you can subscribe for free and you'll get reports potentially about thousands of issues every single day. We provide you information about open services, reflected open services that can be used for amplification DDoS. So you have, if you're a big provider in ISP, you can get an idea of who's abusing your network in what way, and potentially track these attacks, as well as work to minimize your exposure and your client's exposure to these kinds of attacks. This is an example from the Dominican CERT in the Dominican Republic. They have built an observatory, a public one, which you can connect to on the URL here and observe what is happening in terms of infections on a daily basis in the Dominican Republic. And again, this is all based on our data. So this is at a country level, but also if you're an ISP that has quite a large customer footprint, you'll also get quite a lot of data. So you can build these kinds of panels to have an idea of what threats look like and how they change on a daily basis. So where do we really collect all this data from? Well, I've touched on this a bit, and there isn't maybe much time to go into the details, but just to give you an idea, we scan the internet for over 50 different services every single day. So all the over 4 billion IPv4 addresses are scanned by us every single day. So we can actually pick up configuration changes in your firewalls that when your access lists break and some things are exposed when they shouldn't, this can all be picked up by these scans. Honeypots and honey clients, we have nearly 3,000 honeypots around the world in 90 countries collecting data. We have one of the biggest malware repositories in the world, approaching 1.5 billion malware samples, where we have hundreds of thousands of unique malware binaries collected every day, unique by hash. So one of the biggest of these kinds of setups in the world. We monitor other people's block lists they publish about bad IP activity, and we share that as well. We take over botnets and malicious infrastructures, whether they are cybercrime related or APT related, and we partner with the industry and law enforcement to to collect information. And so we see essentially 5, 6, 7, up to 10 million different bots connecting to this every day across nearly 400 different malware families. And as I said, we engage in a lot of international data sharing partnerships where built on trust, where we essentially act as a trusted third party for feed exchange. So to wrap up, essentially, who are we? Something I could have started with as well, but essentially we are an entirely non-profit security organization that has a mission to make the internet more secure for everybody. We are pretty passionate about what we do. We are happy to help in any way we can. We try to be impartial, striving to be more transparent as far as we can, and essentially try to offer you and the community data for free, and hopefully be as useful as possible. Another slide showing basically the scale of our operations. We have petabytes of data storage in place to actually facilitate all of this. So we're actually a pretty huge operation in terms of network infrastructure. We have a data center with thousands of hundreds of servers to handle all this large amount of data. And to wrap up, we are currently engaged in a UK Foreign Commonwealth and Development Office supported project to expand our outreach to the Indo-Pacific, where we want to expand our recipient base of shadow server free feeds in the Indo-Pacific region. So we would really like you to sign up to our feed reports. And also if you are a hosting provider, an ISP, or any other entity that is willing to host a honeypot sensor from us, we are happy to engage you on that. And so we're seeking essentially connections to VPS providers, hosting providers, data centers in the Asia Pacific. And again, subscribe to our reports, please. If you haven't, it is really easy, and yes, they are really free. So thank you very much for having the opportunity to present today. I'm happy to take any questions. Thank you.
Okay. Okay, thank you very much. Thank you for presentation. We are very limited time slots. So, but there is a 3 Q&A, and Peter, could you confirm these Q&A box? And at first, I'd like to read each 3. We have only 3 Q&A. And one is any API access to the data so that I can build my own report.
So yes, we provide, the default way is to actually get them by email or download links, but we do provide an API now. It's in a beta stage, and you can connect to that and use it. It's a RESTful API, so it should be easy to use.
Good. And next is since I have a bunch of server running at the various data center and the different domain name and run for the various NGOs, can I have a shadow server arrangement?
Yes, that's definitely yes. So you just need to provide the IP address of these servers or associated data domain names and subscribe.
Great. And the last question is, what is the expectation for the network operators or national CERT who receive these data? Some operator only cared about DDoS attack against their own network.
So our expectation is that you will use this information to improve your cybersecurity resilience or fix the problems that we detect. Of course, there's no obligation from us to do that, right? The information is there to help you So we will not evaluate you or check up on you or this kind of stuff. You use it to help yourself, and we hope that you actually do it, and we hope it is useful to you. So there's no obligations about the other statement about the DDoS attacks. We do provide information about DDoS attacks against your own network as well. So if you want, you can always also be selective in the reports you take. It's really up to you. There is we hope you use it for something good.
Okay, good. The last question is RIR who is the only measure used to validate ownership of the resource to the subscribe to the report.
It is one of the mechanisms used. It's not the only one. It's not the only one used. So we do try to do some additional checks. There is also the like domain name, email address you provide that should be associated in some way, or maybe depending on the situation with the organization, some references. So we do try to do some other checks, but yes, who is one of the mechanisms.
Yeah, thank you very much. Peter, let's close the session. I really appreciated your presence. So very useful.
Thank you.
Yeah, thank you very much. Thank you for audience and thank you for our presenter. It is a very useful session for the operator, network operation. I'll pass to the Tash for the wrap up.
Thank you, Suchiya-san, and thanks all the speakers and all the attendees for attending the session. I think we ran a bit over time, but all good because the discussions were all great. Please don't forget the session poll that I can see. Please let us know what you thought about the session. Once that is done, folks, we have the NOC session coming up 5 minutes from now because we overran a bit. So looking forward to see you all there at the NOC session. And the slides and the recordings of all the sessions will be made available on the conference site. So those of you who were wondering if you could, or maybe those of you who were taking photos of the slides, don't worry, it'll all be made available at the conference. And once again, thank you to all the speakers. Thanks for your time. And thank you to the audience. See you at the NOC session. Thanks, everyone.